Welcome to the mathematics in my channel. In this video we are going to find the sum of this infinite series. Okay, how to begin? Well, first I'm going to take the sum is equal to capital S. So then we can write this is equal to n is equal 0 to infinity. Now here 2 raised to the n minus 1. So we can write this is 2 raised to the n times 2 raised to the minus 1. So 1 over 2. So we can write outside 2. And then here minus 1 to the n over here n factorial. Here 2 raised to the n times here n plus 2. So now here we have n plus 1 over n plus 2. So we can simplify 1 minus 1 over n plus 2. Now if you take n plus 2 as a common denominator, so n plus 2 minus 1, n plus 1 over n plus 2. So this is okay. Then we can split this sum into two different sums. So we can write 2 times n is equal 0 to infinity minus 1 to the n over n factorial times 2 raised to the n, then here minus sign, so minus 2 times 0 to infinity minus 1 to the n power over n factorial 2 raised to the n times n plus 2. Okay, now this is very easy infinite series. It is easy to calculate. So we know e to the x is equal to 1 plus x over 1 factorial plus x square over 2 factorial plus so on, and we can write e to the x as an infinite series. We know 0 to infinity x to the n over n factorial. Okay, then if we plug in minus 1 half here x instead of x, if we plug in minus 1 half, we know here e to the minus 1 half is equal to 1 over square root of v, and here sum of 0 to infinity. Now instead of x, minus 1 over 2, so minus 1 raised to the n over 2 raised to the n times n factorial. This is our series. So now we know this is equal to 2 times 1 over the square root of e. Okay, then here minus 2 infinite sum 0 to infinity minus 1 to the n power. Now I am going to multiply by n plus 1, and also we should divide it by n plus 1. So here n factorial n plus 1 times n plus 2. Okay, then we know n factorial times n plus 1 times n plus 2 is equal to n plus 2 factorial. So we can write this is equal to 2 over the square root of e minus 2 times infinite sum here. Now minus 1 to the n power n plus 1 over 2 raised to the n times n plus 2 factorial. Okay, then here now we have s is equal to 2 over the square root of e minus 2 times, now I am going to take the series is equal to s1. Okay, then okay, here 2 is a common factor, so 2 times 1 over the square root of e minus s1. Now we should evaluate s1. So we know now s1 is equal to sum of 0 to infinity minus 1 to the n power n plus 1 over 2 raised to the n plus 2 factorial. Okay, then here 0 to infinity. Now I need to change the denominator like n factorial. So here we can take now n is equal 2 to infinity. Here 0, here 2. So we should plug in n minus 2 for n. So we can write here minus 1 to the n minus 2. Here n plus 1 minus 2, we know n minus 1, and here 2 raised to the n minus 2 times here n plus 2 minus 2, we know n factorial. Okay, then here 2 raised to the n times 2 raised to the minus 2, so 1 over 4, so we can take 4 outside of the sigma notation, and here n is equal to infinity. Now here minus 1 to the n times minus 1 to the minus 2 power, we know minus 1 to the minus 2 power is equal to 1. So here we have minus 1 to the n power times n minus 1 over 2 raised to the n times n factorial. Okay, then here this 4 I am going to take left hand side, so s1 over 4 is equal to now we can simplify this part times n and this part times minus 1, so we can split this sum into two different sums. N is equal to infinity minus 1 to the n power times n minus 1 to the n power times n over 2 raised to the n times n factorial minus n is equal to infinity. Now minus 1 to the n minus 1 to the n over 2 raised to the n times n factorial. Okay, then we can simplify, so we can write now s1 over 4 is equal to here we have sum of n is equal to infinity minus 1 to the n power here n factorial, so we can simplify here over 2 raised to the n times n minus 1 factorial. And here now this is familiar with us because 0 to infinity minus 1 to the n over 2n times n factorial, we know 1 over e, but if we take n is equal to infinity, we should subtract this part when x is equal to minus 1/2. So we can write this is equal to 1 over square root of e minus 1 over square root of e minus now here 1 minus 1/2, so 1 minus 1/2. Okay, then we can take this part in left hand side, so s1 over 4 plus 1 over square root of e, here 1 minus 1/2, we know 1/2 minus 1/2 minus, so plus 1/2, so here minus 1/2 is equal to, here we have now here n minus 1 factorial, so now I need to also change this part as a n factorial. So here now I am going to take here n is equal to, so n is equal 1 to infinity, so now minus 1 to the, now instead of n plus 1 over here 2 raised to the n plus 1 times n plus 1 minus 1, we know n factorial. Okay, then here we know now this is equal to, here 2 raised to the n times 2, so we can take 2 as a factor, so 2 here minus 1 to the n minus 1 to the 1 power, we know minus, so minus 1 here n is equal 1 to infinity minus 1 to the n over 2 raised to the n times n factorial. Okay, again this formula, but here n is equal 1, so we should subtract 1, so we can write now this is equal to minus 1/2 1 over square root of e minus 1. Okay, then we can simplify, So now I am going to isolate the s1 over 4 is equal to here minus 1/2 times 1 over square root of e, then here minus 1 over square root of e, here we have plus 1/2, here also plus 1/2. Okay, then if we simplify, minus 1 minus 1/2 minus 3 over 2 times 1 over square root of e plus 1, then we can isolate the s1. So s1 is equal to, for here minus 3 times 2, so minus 6 over the square root of e plus 4. Okay, then we know s is equal to in a previous equation 1 over square root of e minus s1. Okay, now we can plug in here. So 2 times 1 over square root of e, here minus, so here minus, so plus 6 over square root of e, then minus 4, so minus 4. Now 2 times here 6 plus 1 7, so 14 over square root of e minus 8. Okay, this is the answer.